So now that we've finished up equations, the next step is to work on inequalities. This is where I start to lose some people. For some reason, equations make sense because there's one answer. And as soon as we get to inequalities, then people start to freak out. Well, here's a real world example. If I said, I'd like to go to the store to buy alcohol. Well, I'm not allowed to buy alcohol because I'm not 21. Really? Kids argue with me on that. Well, I'm not 21, I'm 32. So, am I allowed to go to the store to buy alcohol? You don't have to be exactly 21. You can be 21 or older. That's an inequality. I could be 21, 22, 23, any age that's 21 or above. Well, that's the same concept when it comes to math. Now, instead of just x equaling 5 or x just equaling 21, it might be 21 or bigger, or it might be smaller. Inequality means instead of just one exact answer, it's that number or anything greater or anything less. So we have 4 different options. We have greater than, less than, or when they put that little line underneath right there, it means it can also equal. So we could have greater than or equal and greater than or less than, or equal. So you're going to solve these problems exactly the same way we did when we solved equations. Instead of the line going down through the equal sign in the center, now we're going to have that line going down through the inequality sign. The way I would read this is saying x plus 4 is greater than or equal to 10. Remember from like 4th or 5th grade when your teacher stood up front and said the alligator's hungry. The alligator always wants to eat the one that's bigger. So if it wants to eat the x and the 4, that means the x and the 4 are bigger than the 10. But what does that little line underneath mean? Remember that little line is equal. So it can also be exactly 10. Well, now let's just solve this. My variable is x, so I need to get the x completely by itself. Well, in order to get that x by itself, I have to get rid of this plus 4. Well, the inverse of plus 4 is just minus 4. And just like equations, what you do to one side, you have to do to the other. And remember, I want the inverse operation lined up all the way down the problem. So if I have a 4 and a minus 4, it cancels out to 0, so I can just cross it off because it goes away. But I still have on that left side the x, and 10 minus 4 becomes 6. But remember, it's not an equal sign. We have to bring that down. So really, the way that I would read this is I would say x is greater than or equal to 6. But then, not only do I have to graph with inequality, or not only do I have to solve with inequalities, I also have to graph. So a lot of people think 0 has to be on the number line. It really doesn't. These little arrows on the end mean numbers are going to keep going in both directions. So I can pick any part of the number line that I want. Well, if 6 is in my answer, then I need 6 to be on the number line in my graph. So I'm going to put that number in the middle. But now I need numbers to the left and numbers to the right. Remember, to the left, numbers get smaller, so I would go to 5 and 4. And to the right, the numbers are getting bigger, so I would go to 7 and 8. So in order from left to right, they should go 4, 5, 6, 7, 8. For my class, I require 5 numbers on the number line. The number in the answer, 2 numbers smaller, and 2 numbers bigger. So now we actually have to graph. Well, 6 is the number in my answer, so I'm going to put a circle on 6. If 6 is allowed to include in my answer, then I color it in. So this little line right here means it's greater than or equal. So if it has that equal, then not only do I put the circle, but I actually color it in. Because it means 6 is included in my answer. I'm allowed to have 6. But then x isn't just equal to 6, it's greater. Well, what's another word for greater? It means the same thing as bigger. So what numbers would be bigger than 6? 7, 8, 9. So from this circle, I'm going to draw an arrow. Technically, I could have 9, 10, 11, 12, any number to the right of 6 on the number line. So you need to make sure you end that with an arrow because it's going to keep on going. So the same type of problem right here. Draw that line down through the inequality sign. But remember, anytime a number has 2 signs, what's my rule? We need to rewrite that problem. So I have the M, and I have that 2, but instead of 2 signs, I need to make that 1. Right here, 2 negatives cancel out. So if those 2 negatives cancel, it really means I have a plus sign. So I have my variable I need to get by itself, but I have to get rid of that plus 2. To get rid of a plus 2, I have to subtract 2 from both sides. When I bring down that M and I bring down my sign, then 5 minus 2 is just 3. So that's my solution, but I'm not done yet because not only do I have to solve, I also have to graph. So since 3 is in my answer, I'm going to put that number in the middle. To the left of 3 would be 2 and 1. So going in order, 1, 2, 3, I'd have 4 and 5. I'm going to put that circle on the 3. Now, if there was a line underneath this, I would fill in that circle because that would mean that it could equal 3. But it doesn't equal 3, it's just less than. And some people argue, well, if it's less than 3, why not put the circle on the 2? Here's why. In between 2 and 3, there's a lot of decimals. You could have 2.5, 2.8, 2.9. All of those are still less than 3. So all of those decimals in there still have to be included in our answer. So I'm going to put that circle on the 3. Then if M is less, because see it wants to eat the 3. If it wants to eat the 3, you can even put teeth on here if it helps you out. If it wants to eat the 3, that means the 3 is bigger than M. Well, if 3 is bigger, that means the M has to be smaller. Well, numbers smaller than 3, 2, 1, 0, and all the negative numbers that are going to the left. So what if we have multiplication? If 5 is touching the y, remember that means multiply. So to get rid of multiply, we have to divide. So I'm going to divide 5 on both sides. That gives me that 1y. I bring down my sign, and 25 divided by 5 is just 5. Now how do we graph that? 5 is going to be in the center. So to the left I have 4, 3. So 3, 4, 5, 6, 7. Am I going to have an open circle or a closed circle? It can equal, so my circle is going to be closed. Closed just means I color it in, so it means 5 is a part of my answer. And if it wants to eat the 5, that means 5 is bigger, so the y is smaller. All I care about is my variable. If the variable is smaller, it's going to go to the left. Now what about dealing with negatives? When I subtract 7 from both sides, this is where I still see people making a lot of mistakes. Negative 2 and a minus 7 goes back to our integer rules. This 2 is a negative. This 7 is also a negative. So those signs are the same. Remember, same sign, add and keep. So I actually have to add 7 and 2, which makes 9. At this point, people say, well, don't the 2 negatives cancel out? Remember, that's multiplying and dividing. When I'm adding and subtracting, it's same sign, add and keep. If I keep, that means I have to keep that negative, so I'm going to have a negative answer. So I would read this as n is greater than negative 9. This is where some people get tricked on the number line. when I go to the left, I'm going to get smaller numbers, which actually means with negatives, I'm going further into the negative. Remember, if I have 0 on the number line, as I go to the left, I have -1, -2, -3, -4. Numbers are going further into the negative when I go to the left. So to the left of -9 should be -10 and -11, going further negative. So if I finish out my number line, I have -11, -10, -9, -8, and -7. It's an open circle because it's not equal. And the n is greater. Remember, what's another word for greater? It just means bigger. Where do numbers get bigger? I understand 10 is bigger than 9, but not when we're dealing with negatives. When numbers are getting bigger is as we go to the right toward the positives. 1, 2, 3, all the numbers are getting bigger on the number line when I actually go to the right.